So, we're looking at modelling. And modelling in terms of mathematics is trying to find some sort of mathematical formula or function that will describe the motion of an object. So let's consider a basketball shot. Now, you could just draw it really accurately, but to be honest, it's good enough to say, let's say that's the player taking the shot, and the basket is over here. Now, you'd have to get this information from the question, so you know the dimensions that we're looking at. But for the ball to go in, you have to visualize what's going to happen. Now, I think most of you would see that something like that is quite realistic. What won't be realistic is if we were to do something like this. That just wouldn't make sense. I suppose what could possibly make sense is a straight line off the basketball and then bouncing in. That's a possibility, but it's quite difficult. So we're going to stick with this. And this is a parabola. It's actually a negative parabola, you know. And you might need to think, okay, you might want to put on, okay, the floor is here, so you would need to know what is the height above. So maybe, absolutely certainly you're going to need to know a couple of coordinate points. So maybe it's been thrown at, let's say it's been thrown 0 on the x-axis, and it's been thrown from a height of 2 meters. So, you know, if you're every 1 meter 60 tall, you're an extension of 40 centimeters. And maybe you want to have this point here, and that point there. Well, you get this information, but maybe that is going to be at 3 meters. Who knows what that is going to be? Well, you will know because you've given information in the question. Now, how far away that is, again, you get this information from the question. Let's say it is 5 meters away. And then you need to find another point along this parabola. Let's pick the apex, which is here. And let's say at the apex, it's let's say it's 2.5 meters along, and it is would 5 meters be? Well, we can see what's going to have a look. Now, that's one part of the modelling thing. Other non-calculated parts of the modelling could be you're filling a cup of water. What is the distance time graph? So, for example, let's say you had a cup that looked like this. Could you measure, kind of guess what the was? Let's make it symmetrical. Can you guess what that would look like when you're filling it up with a depth versus time? So time, depth, and what you will notice is it starts quickly and it slows down. It's a curve. Anyway, let's do this example here. In the exam, let's use GeoGebra, but we need to use not just any GeoGebra, but the GeoGebra Classic Suite. The reason we do need to use the Classic Suite is because we need to have the spreadsheet function. So I click spreadsheet. I make sure I click it. Bit too much information on the page. I'm just going to quickly click on the hamburger, click view, and just click off the graphics to give some more space. I'm going to put the information in that I know, and we know that it was 0 plotted against 2. It was 2.5 plotted against 5, and finally I need to just go and quickly remember, just going back into the previous, it was 5, 3. 5, 3. Click enter. I then select 2 variable analysis, select all my data. Okay, 2 variable analysis, get the data. Regression model is a polynomial, and what you want to copy down is y equals the bit there. So the function that you're looking for this is y equals minus 0.4 x squared plus 2.2x plus 2. And that's how you do the question. I hope that helps you.